Okay, so let's start. So welcome everybody. I'm hoping that you have a great time at Android Makers. Today I'm going to be talking to you about Gradle and how to make things more efficient for you in your own projects. But before that, let's introduce myself. My name is Xavier Gouchet. I'm the lead Android engineer at Workwell. And I've been fluent in Android since the cupcake years, so it's 2009 for those of you who weren't born yet. And you can find me online using the same handle on GitHub, LinkedIn, Twitter, Stack Overflow, and everywhere. Just a brief slide about Workwell. Our vision is to make employees happier, more productive, and more connected at work. And so we build a platform that integrates all the services that you can find for your workplace. So it could be parking, food delivery services, concierge, nursery, fitness, whatever exists in your company. Just also for everyone, if you want to follow the slides, if you're in the last rows, you can download it directly from this link. So bit.ly/rockthegradle, and you have all the slides already there. So, let's start. Before we dig a little bit into the meat, let's see a brief Gradle introduction. Let's see first a show of hands. Raise your hand if you've already configured a project in Gradle. Okay, good, everyone. If you've written a custom task in Gradle, good. A custom plugin. Okay. If anyone has followed the Kotlinify your Gradle by Alexander yesterday, okay. So for you, maybe there's going to be a couple of slides that overlap with Alexander's talk, but hopefully we're going to have more stuff in here. So, what is Gradle? So the main question is, so all of you use it, you all know about it. It's basically a build system. But first of all, it's general purpose. So it can be used for Android projects, it can be used for Java projects, Groovy projects, Kotlin projects, but also C++ projects or any kind of project you want, because basically, even though it's written in a Groovy and works on the JVM, it can handle almost anything. And the core feature of Gradle is that it's a dependency management system. And it's dependency in all the senses. So it's library dependencies, but also a task dependency. So what it does, it's a build management that is dependency based. We're going to dig a little bit later in this. But basically what it does is it knows that you have stuff that can have dependencies, and it knows how to order them and make the graph for those dependencies. So what's the Gradle algorithm? So you're inside Android Studio, you click on the green arrow to run your project on your device, or you're in the command line and you're starting a specific task or a list of tasks. What happens at that moment? The first thing that happens is that Gradle initializes itself. So it's first going to do a bunch of stuff. So it pops either it has already a daemon, or it just creates a new JVM. And it's going to look around, and it's going to look at what are the projects around. So basically, it's going to just look if there is the settings.gradle file that lists the modules in your project, and it's going to create a bunch of project instances that are empty by default. Then you have the configuration phase. The configuration phase basically is going to run your Gradle scripts. So everything that you write inside the build.gradle is run inside this phase. Everything is run. So basically, it's going to parse your file, and whenever you have apply plugin, it's going to run the actual plugin code. When you have a bunch of DSL that configures Android or find bugs or anything, it's going to actually use this configuration to update the project instances that were created. And then you have the execution phase. So the execution phase, it's going to take a look at which tasks you ask for, and it's going to generate the task graph to know which tasks depends on which task. It's going to list which it needs to run in which order, and then it's going to execute all the tasks. So One of the little known feature of the Gradle system is the build source folder. The goal of the build source folder is to allow you to configure the way Gradle works when it reads your build scripts. So basically, when you have your project structure, you have something like that. So you have your project folder, you have your basic settings.gradle and build.gradle file at the root. Most of you should already know about that. You have your module folder, so basically the app folder and maybe some other modules, each with a source folder and a build.gradle, and you're going to have also a build folder and other stuff, but basically this is what's important. And then you can create a build source folder. So build source is going to behave like any module, but it's a reserved keyword. So it's a specific module that is going to be used by the Gradle system during the initialization phase. So you can also have a source folder, you can have a custom build.gradle, even though you don't really need one, and you can have an empty settings.gradle for some specific cases. So what can this build source folder do for me? Basically, it can help you do a bunch of stuff, but some example that we're going to see is to have a better dependency management. You can have helper classes or methods, custom tasks in dedicated classes, or even a custom plugin. And one of the main features of the build source system is that it's local code that is versioned with your project. So basically, you can create all of the things, a plugin or helper classes that is already inside your project and that lives with your project. So how does it work? It works like any module in your project. So if you know how to create a Gradle module, you know how to create the build source. It just has this reserved keyword. It's compiled and tested before any Gradle task is run. So if you look back at the Gradle algorithm during the initialization phase, it's going to compile, build, and test everything that is in the build source folder. And then it's going to create a jar from this and add it to the class path before it actually reads any of your build scripts. This means that anything that you put in your build source folder is going to be available inside your build script. It can work in Groovy, which is a default, but you can also make it work in Java, in Kotlin, or basically any language that can build to the Java bytecode. So let's dive directly into the good stuff. The first step to have this is create a build source folder. Then, well, that's it. By default, the build source folder has a default build.gradle that you don't have to add. So this is what the build.gradle, the default build.gradle is for this module. The first thing is that it applies the Groovy plugin. So basically, if you just want to write something in Groovy, you don't have to do anything else. And as for dependencies, it adds the Gradle API so that you can write plugins or tasks or specific things related to Gradle. And the local Groovy, which is basically, it's going to find the specific Groovy runtime for your local computer. So step 2, if you want to work with Kotlin, which is what I'm going to do, you can have more things inside your build.gradle, so you can specify things as you want. First thing is to add the Kotlin plugin, and then you can add a bunch of other dependencies. And this is going to be merged with the previous build.gradle. So it adds to the already known Gradle plugin and Groovy dependencies. If you take a look at this, you can notice that it doesn't use anything that you could define inside your main build.gradle file. Because, as I said, this is run before Gradle actually look at any build.gradle file inside your project. So we can depend on any build script dependencies that could be defined, or any repositories defined in the main build.gradle. You have to add this all in here. So, first example that I thought about is dependency management. So most of you know or already use the X keyword to add versions or libraries directly inside your Gradle file, or maybe in a specific Gradle file. But we can do even better. So, for instance, this is what a pretty standard app/build.gradle file looks like. So we have a Kotlin dependency. I have a bunch of Android support libs. And after, well, inside our build source folder, so in the build source/source/main/Kotlin, and maybe a package name, but it was too long for my slides, you can create something like that. So I have an object, which is going to be a singleton, called dependencies, in which I have a versions object and a libraries object. So the versions is going to list which version of each dependency I want, so that I can update the version for every group. And then, then we have the libraries object, which is going to define a list of dependencies. So for instance, in here, so basically you have this whole thing that's going to reference here my versions of Kotlin. That's going to say, okay, this is what a Kotlin dependency is. And this can, you can create also an array of dependencies to list all the Android support libraries. So here I use the JVM field. If you're not familiar with Kotlin, basically what it does is it tells the Kotlin compiler to make it an actual field that's visible from outside of the library's object. So if we go inside our app build.gradle, this is what it's going to look like. So basically, instead of having a string that defines what's our dependency, we're going to reference an object. So you have code completion. So when you start typing dependencies, you can have the code completion, then libraries, then the name of your dependency. So each of your dependencies are named. You have also the support libs is a list of dependencies that are bundled together. So whenever you have multiple modules, you can have something like that. That's pretty easy to use. So whenever you are in a new module, you can say, okay, I'm depending on Kotlin, I'm depending on RX, I'm depending on OKHTTP. And basically what you can do is, okay, I just name my dependencies without having to type all the list of all the libraries that I want. And because everything is centralized inside your build source, it's in a jar whenever Gradle is going to read your build.gradle. So you can change the libraries for all your projects in one place. And if you need, like for instance, you're using retrofits, you want to add another extension to retrofit, you can just add it inside the dependencies object, and it's going to be there for everyone that uses it. So pretty useful. Then you have the, you can create some helper classes and methods. So just a very, very basic example. Here I'm going to create, again, an helper object, which is again going to be a singleton. I could create a class, but for my example, it doesn't really make sense, so just using objects. And I create a method, say I'm thirsty, and it's going to just make a loop and print things. So not very interesting, but basically it shows whatever you can do with the thing. I'm adding again some JVM annotation for Kotlin to make sure that it's a static method and that I'm creating the overloads. Creating the overloads, it's because here in my methods I have a default value for the count parameter. So JVM overload is going to say, okay, I'm going to generate actually two methods, one with the parameter and one without, so that I can use both from my build script in Groovy. And so here's something that you can do. You can create your own task and say, okay, whenever I execute my task, the last thing that I'm going to do is I'm going to call my helper I'm thirsty method either without a parameter or with it. So this is pretty abstract because, yeah, it's just a for loop that prints things. But you can actually do something more concrete. So we're going to look at a real example. That's something that we did at Workwell, where basically we have shared translation files between iOS, Android, and Windows Phone. And basically the idea is that we have the same wordings for common actions that are applicable on all the devices. And we want to translate them once. So we have them in a centralized server. And what we want to do is export them in different files depending on which platform. So on Android it's going to be the strings.xml, on iOS or Windows Phone is going to be something else. And And so basically, we want to make a plugin that's going to retrieve all those the strings dynamically whenever we want to do a build. So the first thing we want to do is to create a task implementation, a custom task. So on my object DOM, I create a class. First thing that you need to know is that the class needs to be open. So Kotlin by default makes everything final, but Gradle actually creates its own implementation of your that is a child of your task class. So you need to make it open, or otherwise you're going to have some errors. And I just extend the default task. You could extend any of the existing tasks. There are a bunch of tasks already known in Gradle that you can work with the file system or can work with generating jar files or stuff like that. And whenever you want to make a task, you have to have at least one method that has the task action annotation. If you want, you can have more than once, but the thing is there is no predetermined order in which they would be executed. So if you have different tasks that need to be run, different subtasks that needs to be run in a specific order, just call them from a single task action method. So this method needs to be void and have no parameter. I'm going to have a couple of parameters in here. So basically, I'm going to list the different languages that I want to download and a path in which I want to store the strings.xml files. And then it's basically a simple loop for each language that I want. I'm going to download a specific string.xml at a given URL. So right now it's a local URL. So Fuel, if you don't know it, just parenthesis, it's a Kotlin library that allows you to very simply create API requests or download files pretty easily. So this is something that I like to use for my plugins. So here we are going to download this file. So we generate the correct URL. We're going to just define the destination. So based on the path, we are going to, which is going to be the path of the project, we generate the correct path. So path/source/main/res/values dash the language string. And then we're going to have basically just in the response, we're going to just print the status code of the request. So it's pretty simple, and basically what it does is in your build.gradle file, you can then create your own task and say, okay, this is a task that uses the type download strings, so which is the class I created in my build source folder, and inside your block you can just configure it and say, okay, my languages are going to be English and French, and the project base path is going to be the project territory. So pretty simple. But we can do better, because right now we need to create ourselves the task, we need to give it the project directory, so it's something that could be automated. So going further, we're going to add an extension, and we're going to add a task dependency, because right now the task only lives by itself. We want it to be part of the global application build system. So we're going to create an extension. An extension is basically a data class, or kind of a data class, but we need to make it open. And it's going to have everything that we want to configure. So again, we're going to have the different languages we want to download and the base URL for the remote host, because we want to configure it, of course. And then we're going to create a plugin. So creating a plugin is fairly easy. You just extend the plugin interface, and you're going to override the apply method that gives you your project. The next thing is to create an extension. So creating an extension is basically allowing the users of your plugin to use a DSL to configure your extension. So it's basically like when you do Android with the brackets, it's an extension. When you do for like find bugs, you have find bugs and brackets, it's an extension. So here we're going to create an extension that's going to be called remote strings, and that use our remote ext class. So basically this line is going to say, okay, I'm going to create an instance of the remote ext class and allow people to configure it using the remote strings keyword. Next thing is going to be creating a task. So again, I'm creating a task called download strings, which is going to be implemented by the download strings class that I created earlier. And on it, I'm going to apply a bunch of things. First thing is that I'm going to say myself that the project base path is going to be the path of my current project directory. And I'm going to also add a property that is going to be my configuration. So basically, whenever the task runs, it can look at what was the configuration inside your Gradle file. So then inside your application build.gradle file, you can just import your class, apply the plugin, and then here you have the DSL that says, okay, I'm just configuring remote strings and say the language and the remote host. Just a side note on task management, what we can do inside our plugin is say, okay, I want my task to run before the application generates all the resources for me. So what I can do is, inside my apply method in my plugin, say that after the project is evaluated, so basically after every plugin has created all the tasks that we want, and actually, it's the Android plugin created all the tasks that are required for an Android project or an Android library project. I'm going to say that all the tasks that have the generate res value class, so it's the task that basically takes all your resources and is going to generate the r.java file. I'm going to say, okay, these tasks, these generate res values tasks, are going to depend on the task I created. So before we generate the r.java, I'm going to actually download the new strings.xml file to make sure that my strings are up to date. Here I'm using the it depends on. So who here already used the depends on methods? A couple of you? Yeah. So basically what it does, it creates a strong link between the generate res value task and my download strings task. The dependencies, you can have basically two kinds of dependencies in Gradle. The depends on and finalized by. Depends on says when I want to run my task, I need to actually run another one before. And finalized by says after I finish running my task, I need to run another one after it. So it forces some tasks that you didn't specify to be run actually. You have other things that you can add to change the order of tasks when they are run by Gradle, and it's not a strong link. It basically means, it doesn't mean, it's a soft link because if you only specify one of the two, the other one is not going to be run. It just says that if the two are run during my, my execution phase, this is the ordering that should happen. So you have the must run after and the should run after. The must run after says, okay, my task needs absolutely to run after another one, if they are both present. So it's simply to say, okay, if another task is called, then it needs that mine must run after it. But if it's not there, I don't have to call it. Should run after is a little bit trickier. Basically, it says, okay, if this other task is there, if possible, I want to run after it. When you call a bunch of tasks in the command line, it's actually using the should run after because it's a soft ordering. And what it does is, if it doesn't break the dependency graph, I'm going to run them in the order you specified. Also, if you have multiple processors that run in parallel, and one of them is ready to run your task, and the task that it should run after is not finished yet, it can still run before for performances. So should run after is more like, yeah, it would be better, but if it could still run before the should run after. So anyway, let's go even further. So right now we are downloading strings for my main flavor, but what if I want to create a DSL to configure flavors separately? Because basically, maybe I have a free version of my application and a paid version of my application. So hopefully, obviously, I don't need all the strings in my free version. I need just a bunch of them. And maybe I need some strings specifically for my free version and some for my paid version. So we are going to add something that's called a named object container. So basically, I'm going to create a variant object which has a name, so which is going to be the name of the variant. So the variant, it could be a build type, debug or release. It could be a flavor that's going to be free or full, or it could be actually a variant, so free debug or full release or anything else. And for each variant, I can specify a list of languages. And so in my remote extension, I'm going to add a named domain object container, which is basically an implementation of a set, but it's a set that can be configured from Gradle using a DSL. And I need to add this method that basically just going to say, okay, I have a configuration that has been defined in the user's build.gradle file, and I'm going to apply it to my variants. So this is the magic method that's going to create all your variants instances. Inside my remote plugin, it's basically the same thing. I'm creating my extension, but so just exactly like before. But I have another thing that says, okay, for my variants objects, I'm going to actually create a container that uses my variant class implementation. And so now inside my app/build.gradle, basically you can have something like this. So I'm saying that for my remote localization, I have, so again, my remote host, but I also have a list of variants. So in debug, I only want the English language because basically it's just for debug and I'm only testing in English. And I want it to build fast. In free release, I want to have a list of French and English. And in full release, I want French, English, Spanish, and Deutsch. And basically, inside the task that's going to run, because the variance object is going to be a set, you can iterate through it to list all the language. So basically, it's just another loop that's going to go around the loop that iterates over the languages. So what I said earlier is that the build source folder is going to be compiled and tested whenever your application, whenever a task is run in Gradle. And test matters, you should test your code, and every code. So basically, you can create a test class that's going to test your plugin. So this is a basic setup that you need to do. You're going to have a fake project instance. So basically, Gradle has something that's called Project Builder that can create a very simple project instance. And then you can say, okay, I want to apply it the app plugin, so which is the Android application plugin directly. And then I'm going to apply my own plugin. And then you are going to call evaluate. If you do that in Groovy, you can call it directly. Inside Kotlin, you have to use a ugly hack reflection stuff. Because basically, you need to call the evaluate for your plugins to be run. And the evaluate is a hidden method. It's not in the public API, which means that they have, like, since 2011 or earlier, I think, a task to make something easier for testing plugins. It's not done yet. So basically, you have just ugly hack to call the evaluate method on the fake project. And then inside your test, you can say, okay, I want to test that my plugins adds the extension. So you're going to say, okay, I'm going to find the extension that has my name, and I'm verifying that it has the correct class. And I'm going to also verify that if I look for a test that has my name, it has also the correct class. So pretty easily. If you want to unit test the task itself, it's trickier because you can do it directly. Basically, you can't instantiate a task directly. It has to be instantiated by the Gradle system. So you can do it in an integration task. You can create a fake project with a fake build script and then ask Gradle to run it but we want to unit test it. So what you do is delegate all the business logic to a dedicated class. So basically what you can do is say, okay, I'm going to have an interface that is a downloader that's going to do everything that says, okay, I'm downloading something from a URL to a destination file with a bunch of callback. You have a fetcher that basically has a downloader as an input, a project base path, and the configurations that are going to list all the variants. And then you can update your task to look like this. So basically the task itself only has a dependency on which you just give everything, and it doesn't do any work itself. So we're just going to create a fetcher, an implementation of a fetcher, and then we're going to say, okay, I'm going to actually call the fetch strings with the default downloader, the project base path, and the configuration that comes from the build.gradle. So then the fetcher can easily be tested because it has dependencies injected directly, and the task is itself has minimal code and no business logic. So pretty interesting. So I could go on and on and on about writing your own plugins. I'm just going to go briefly about a couple of tips and tricks to make your life easier. So the first thing is aliasing the plugin. Basically, if you add the Java Gradle plugin, it's going to generate directly all the manifest information in the build source jar file that's going to be added to your class path so that you can create an alias for your plugin. So before earlier, you saw that to use the plugin, I had to import the class directly. Here, I can say, okay, I'm creating a plugin that has the ID remote localization. So it's the ID that's important. The name of the plugin is not really used. And then I give the implementation class full package name for it to know which class to load. And so inside your app, you can now say just apply plugin and just give the name, and you don't have to do the import anymore. So it's pretty useful. You can add a task category, pretty easy too. Basically, inside your task implementation, just have your initialization set the group and description properties. That way, when you do stuff like this, you can have, when you list the task, or inside the right panel inside Android Studio, you're going to have your task directly inside the correct group. So pretty useful too. So here, yeah, you have the maker's task, and it's going to list give your description. So it's interesting. You can define inputs and outputs. So you already know that when you run tasks, sometimes you have the up-to-date message that comes next to your task. Basically, it says, okay, the inputs of your task didn't change, the outputs didn't change, and so I don't have to update the task. So you just have to use some annotation to say what's your input and what's your output. So you can input and output serializable objects, strings, primitives, lists. You can define files, inputs or outputs, directories, inputs and outputs too. You can go even further with a bunch of things. I'm not going to go into details right now, but take a look at it. It's pretty interesting. Internals basically say, okay, it's a property that's not used inside my task. Destroy says, okay, this is going to destroy this file or this directory. And nested lets you say, okay, my object is not serializable, but some field inside of it is serializable. You can also skip some inputs, skip the task when the input is empty, or make some inputs optional. So this is an example of how you could define this. Basically, I create an input annotated method that's going to return a list of strings, and what I'm going to do is create a list of strings based off the variance and language combo. That way, if ever the users change the configuration in Gradle, then the input is going to be changed. Likewise, I define the outputs with the list of strings.xml file that I'm going to create. So if the strings.xml file that were priorly fetched are deleted after a clean, for instance, it knows it and it's going to run it again. If the files didn't change, it's not going to run it. So pretty interesting. So then when you run again the task, it's going to say, yeah, it's up to date, nothing to do. So you prevent your plugin to do a lot of requests. But then it will never update until we change the config, which can be difficult because the translations can change outside of our development. So you can create a fake input that's going to be basically just a date input and say, okay, I want to run it at least once a day. And you say, okay, my input is going to be the date in a ISO format. And whenever the date change, I'm going to just fetch again the strings just to be sure. You can also create incremental tasks. It's going a step further. Basically, if your task has files as input, you can say, okay, my task takes an incremental task input, where you can say, okay, I'm going to iterate over the out-of-date files and do something with them, and I'm going to iterate over the removed file and do something else. So basically, if you have some compilation or if you have source files that generate something else and only a bunch of those source files changed, you don't have to do all the process again. And if the input, the incremental input is not supported, you just do everything from scratch. So what else? Well, you can generate source code. If you don't know it already, you can take a look at the Java Poet or Kotlin Poet libraries, which are very, very nice to generate Java or Kotlin source files. It's fairly easy. So instead of just say, okay, I'm writing text to a file, you can actually define more precisely what you want. You can generate resources, drawbles, layouts, strings, as we saw. You can have custom lints, analysis, anything. What next? Well, first of all, if you use this technique, you can clean up all your Gradle scripts. Basically, remember that everything that's in your project is code and it should be clean and easy to understand. So clean up your Gradle scripts. You can publish your plugins if you've created a plugin and you refined it over time. You can at some point say, okay, it actually could benefit others. You can just extract your build source into a proper Gradle project and publish it on Maven and maybe GitHub. A couple of reminders if you want to use these techniques, that tasks and extensions classes must be open because Gradle is going to actually create subclasses for them. The DSL can go as deep as you need. So we only saw one layer. We only had the variants, but inside the variants we could have even more configuration. The build source is always built and tested. Of course, it's incremental, so if nothing changed inside your build source folder and everything's up to date, it is not going to run it again. But if you change one line, it's going to build it and test it again. And you can also use the apply from to have configurations inside multiple files. So all your DSL don't have to be in a single app/build or Gradle. You can have a configuration file for find bugs, a configuration file for lints and whatever. And as I said, your build code should be as clean as your production code and your test code. So that's it for me. Thanks a lot for your attention. And if you have any question, I'd be really happy to answer them. You can find a sample application that basically takes all these steps in detail on GitHub. And it's all in separated commits, so you can follow every steps of the way. And the slides are again available. I'm going to tweet it just after. Thanks a lot. Any question? It was perfectly clear. Okay. Question here.
You said that a Gradle plugin can generate the resources, so XML resources, I assume you mean, but also, it could also download images. But what about Android manifest? And what about the manifest merger too, if you know, of course?
Oh, I never tried to generate the manifest, but basically I think that you could generate the manifest, for instance, inside the different flavors or just the main manifest. Basically, all you have to do is make sure that the generation of the manifest goes before the Android plugin task that actually needs to read it and merge it. But yeah, I think it could be totally feasible. Yeah.
And do you know an example I could find online that generates these XML resources in an Android project?
I don't have any example in mind, but basically, whenever you want to generate stuff, I actually tried to do something. So it didn't generate XML file, but it generated some Java source file. But the goal is the same. Basically, you're going to say, okay, I'm going to create a folder inside the generated / my plugin / source / flavor inside the module. And say, okay, this is going to be, I'm going to write my XML, so writing XML is fairly easy. All you have to do is make sure that you configure the resources, the resources directory for your Android plugin to add these generated folders. And as I said, make sure that your task runs before the generate app-res task.
Okay, and the last one question, do you know any example that does it for generating Java or Kotlin code? Maybe it could help to know how I should do it for resources.
No, but if you want, we can talk together and we can go through it because, yeah. It's,
okay. Thank you.
You're welcome. Any other question? Okay, well, bon appétit tout le monde.